Now student, after the vector form of Coulomb's law, there is a next topic. It is about the principle of superposition, or also you can say that it is a superposition principle. And one more thing we can say that forces between the multiple charges. Forces between the multiple charges. Well, student, in the Coulomb's law, we can calculate the force acting only between the two charges. Coulomb's law can give the value of the force acting between only two charges, but here system containing more than two charges, or multiple charges, then how to calculate the resultant force acting on a charge? To calculate this resultant force acting on a charge, now we can use the superposition principle. Now we can use the what? Superposition principle. And by using the simple superposition principle, we can calculate the force acting due to the multiple charges. Force acting due to the what? Multiple charges. Okay. So now once again, student, there is a first of all diagram. In our diagram, total there are three charges. First charge Q1, second charge Q2, third charge it is Q3. These all the charges having a position vector with respect to the origin O, denoted by vector R1, vector R2 and vector R3. It is denoted by vector R1, it is vector R2, and it is vector R3. Okay? The total number of charges are 3, Q1, Q2, Q3. Their position vector are with respect to origin, vector R1, vector R2 and vector R3. Chalo. On this Q1, Q2 will be exert the force in this direction. On this Q1, Q3 will be exert the force in this direction. Force acting on Q1 due to Q2 denoted by vector F12. Force acting on Q1 due to Q3 denoted by vector F13. Now force F12 and F13, they form the parallelogram. They form the what? Parallelogram. In the parallelogram, the resultant vector or the resultant force will be produced in which direction? Diagonal direction. So that resultant force due to F12 and F13, it is in a diagonal direction. It is shows that the force acting on a charge Q1 denoted by F1 due to Q3 charge and due to Q2 charge. Now student, from this diagram we can conclude that whenever the system it is containing more than two charges, then the resultant force can be calculated by using the law of parallelogram. The resultant force can be calculated by using the law of parallelogram. And also we can calculate the resultant force acting on a charge due to the force acting due to the vector sum of the force acting due to all other charges. Okay. Now the explanation, it is about the diagram, it is completed. Well student, the first statement, it is given by like this. Coulomb's law gives the force between 2 point charges. Coulomb's law gives the force between 2 point charges. Next student statement, the principle of superposition gives the force on a charge due to the group of point charges. The principle of superposition gives the force on a charge due to group of point charges. Through the superposition principle, we can calculate the force acting on a charge due to the group of charges or due to the multiple charges. Okay? So now the next statement. The principle is based on the property. The principle is based on the one of the property. That's the force with which two charges attract or repel to each other. There is a one property, and that property, the force with which two charges attract or repel to each other are not affected by the presence of other charges. This statement says that student, when the two charges are interact to each other, interaction means what? Maybe the attractive force acting or maybe the repulsive force acting. When the two charges are interact to each other, that time the presence of the other charges around it, it is not affected between the two charges. Whenever the other charges are present, when the two charged particles are interact to each other, then the presence of the other charge it is not affected between the two. It is not affected between the two charges. Okay. Now, student, the next is a statement of the superposition principle. It is a statement of the superposition principle. Well, the statement of the superposition principle, it is very easy. How to give this statement? When a number of charges are interacting, the total force acting on a given charge. When the number of charges are interacting, the total force acting on a given charge is the vector sum of the forces. Exerted on it due to all other charges. Vector sum of all the forces exerted due to all other charges. It is a very simple statement. The resultant force acting on a charge is equal to the vector sum of the forces produced due to all other charges. Resultant force acting on a charge is equal to the vector sum of the forces produced due to all other charges. In short, resultant force can be calculated by using the vector addition, and the resultant force can be calculated by using the law of parallelogram. Okay? So now, student, from the diagram we can say that as shown in figure, consider a n point charges. And so as shown in figure, consider a n point charges Q1, Q2, Q3 up to the Qn. Plates in a vacuum at a point whose position vectors with respect to origin are vector r1, vector r2, vector r3 up to the vector rn respectively. According to principle of superposition, the total force acting on a charge Q1 is given by. According to principle of superposition, the total force acting on a charge Q1 is given by, that is vector F1 is equal to vector F12 plus vector F13 plus up to the it is vector F1n. Where, student, vector F12, vector F13 and vector F1n are the force exerted on charge Q1 by the individual charges Q2, Q3 up to the Qn respectively. It shows that force acting on Q1 due to Q2. This is shows that force acting on Q1 due to Q3. This is shows that force acting on Q1 due to Qn. Well, student, vector form of the Coulomb's law already studied. So now please write down the answer of vector F12 in terms of the vector form. So now the next step can be given by vector F1 is equal to expansion of vector F12 given by 1 upon 4 pi epsilon 0 Q1 Q2 by r square 1 to r cap 1 2. Student, here it is a 1 and 2 number. So they write down the name of the charge Q1 Q2. So here is a 1 and 3 number. Write down the name of the charge Q1 and Q3. So now the expansion of 1 3 can be given by 1 upon 4 pi epsilon 0 Q1 Q3 by r square 1 3 multiply r cap 1 3. Now plus dash plus. Now write down 1n. Therefore 1 upon 4 pi epsilon 0 Q1 Qn by r square 1n and multiply r cap 1n. Okay. Now, student, from this first term, from the second term and from the last term, which values are common? So 1 upon 4 pi epsilon 0 it is common from the each term. Q1 is also common from the each term. So the next equation can be written down. Vector F1 is equal to Q1 upon 4 pi epsilon 0. Q2 remain, r cap 1 2 remain, r square 1 2 remain. Into the next step, Q3 remain, r square 1 3 remain, r cap 1 3 remain. Or into the last step, Qn remain, r square 1n remain, r cap 1n remain. Okay. Now please write down the general form of this equation. Now that general form can be given by like this. It is a vector F1 is equal to, which is Q1 upon 4 pi epsilon 0. Now this addition denoted by sigma. This number are changed, 2, 3 and n is changed. So they write down I is equal to 2 to n. Because the numbers are start from 2, not start from 1. Therefore we write down I is equal to 2 to n, denoted by Qi. And r square 1i, r cap 1i. Because this 2, 3, 3, and these are the variables, and these variables denoted by I. So they we write down again qi upon r square 1I r cap 1I. Okay, now this is our general form of the word superposition principle. It is our general form of the word superposition principle. Now the last statement, it is about this one. The vector sum is obtained as usual by the parallelogram or law of addition of the vectors. Once again student, vector sum is obtained as usual by the parallelogram law of addition of vectors. And the last statement student, all the electrostatics is consequence of the Coulomb's law and the superposition principle. All the electrostatic is the consequence of the Coulomb's law and the superposition principle. So the student, whenever the system is containing only two charge, force can be calculated using the Coulomb's law. But the system containing a multiple charges, then the resultant force can be calculated by using the superposition principle. Okay.